Howdy! I'm going to spend a couple of minutes discussing with you a cloth simulation project I worked on at the tail end of my education at the Art Institute of Los Angeles. So without further ado, this cloth simulation, it's unique in that the cloth does not employ forces of any kind or factor in delta time or change in time in any way. This is what's responsible for the bouncing. If you haven't noticed it yet, you will. As the processor speed fluctuates, so does the rate of the update, though I've made some attempts to control it, unsuccessfully thus far. And this is responsible for the bouncing. This flaw is exaggerated by the fact that running recording software puts additional strain on the processor. This project was constructed in an environment I'd set up previously. OpenGL was used for rendering, and a TGA loader written by my professor was used to load and set the textures. The OBJ loader, however, was mine. Writing this was actually quite a challenge for me. I'd had limited experience with parsing at this point, and my education forbid me to use the standard tool library, the string class, and most devastatingly regex for this assignment. The one luxury I was allowed was scanf, which aids in the process of recognizing tokens or groups of characters separated by whitespace or other delimiters and converting those tokens to numbers. I also wrote the loader to cope with all formats of OBJ files, excepting one that I didn't know existed. If you're unfamiliar, some formats of OBJ contain texture information, some don't. Likewise, some contain vertex normals and some don't. And the format of the OBJ, the syntax, it varies per information available to you. The loader could also cope with models composed of tris, or sets of 3 polygon indices, and quads, sets of 4, which were then obviously broken up into tris prior to being passed to the, I used OpenGL fixed function lighting for the scene, which, as an aside, I do not recommend. It was a pain in the ass. Another challenge I faced was retooling the aforementioned OBJ class to house the cloth so that it could easily be rendered. The thing is, the OBJ class, it wasn't designed with the ability to transform individual vertices. All transformations happened at the level of the object by passing concatenated matrices into OpenGL. Which OpenGL then applied to the vertex buffer and normal buffer prior to rendering. Further, the anchor points of the cloth had to be moved in world space, where all other vertex transformations occurred within the cloth object's space. Essentially, I had to figure out how to build a flagpole that the user could wave around. You might expect methodological changes to be amongst the greatest one would face in writing a cloth simulation, but this wasn't my experience. Provided one tracks and stores the polygon and cloth particle relationships, which optimization already required of me, doing something like adding wind is as simple as offsetting cloth particles by a factor of the wind vector, insofar as it resides along the polygon normal. The rest is handled by a series of passes that resolve cloth particles' positions toward other cloth particles that they're clamped to when the distance exceeds a certain preset value. If you're interested in the specifics of the project, feel free to contact me. I don't have time to explain them here, but I would be more than happy to give you the source code. Thanks.